All right, this video is going to go over properties of logs. I will say before you start, you need to have this written down on your paper. These are like the rules that you're able to use to help solve these things. So let's go ahead and get started. Look at number one. It's a log minus a log. So it's this middle equation here. So what you do is you just say, okay, we've got log base 3 of 63 minus log base 3 of 2. So the bases match on the logs, so that's a good thing. So we don't have to do anything there. And so we can just combine this and call it one log. And when you minus logs like this, it's just of the of sections get divided. So it's just like 63 over 2 with that matching base. This would be my answer. Okay, let's look at another. The next one's a log plus a log. So we're going to be using the first rule here. So number 2, we're going to be using this rule. But there's a couple things going on. So we have 3 log base 5 of 3 plus 4 log base 5 of 1/2. All right, so what you need to realize is this third rule here. If you have a number in front of your log, you can take that and put it as an exponent on the of section of that log. So here's what I mean. This 3 can go away if you call it to the exponent 3 here. This 4 can go away if you call it to the exponent 4. So really what you have is log base 5 of 3 cubed, which is 27. And then you have plus log base 5 of 1/2 to the power of 4 is 1 over 16. So now that we have it just log plus log with no numbers in front or anything, we can use rule 1 here and call it log of a times b. So my final answer here would be log base 5 of 27 times 1 over 16. 27 times 1 over 16. This is how I'm getting this number. So this is my final answer. Okay, look at the next one. You got 4 ln y. Well, ln, well, I guess you could just go like this. 4 ln y. You could just throw this 4 right here, and so your answer could just be ln of y to the power of 4. That one's kind of easy. Same thing with that next one, number 4. So I'm going to skip that one. I'll go ahead and do it just because you'll see something here. All right, if you had -2 log 4x, you can throw this -2 here. Just know it's going to be grouped to the -2. So it's really like log of 4x to the -2 becomes 1 over 4x to the positive 2. So your final answer here is going to be log of 4 squared is 16, and then the x squared as well. This is my final answer. All right, so that's how you're going to do a bunch of these here. Even if it has like 3 things, like look at the next one. 4 log base 5 of 2 minus 3 log base 5 of 3 plus log base 5 of 1/4. All right, so the first thing I would do if I approach this problem would be like, take this 4 and put it here, take this 3 and put it here. And so I'd rewrite this problem as like log base 5 of 2 to the 4th is 16 minus log base 5 of 3 cubed is 27 plus log base 5 of 1/4. All right, so the minus is going to be rule 2. And the plus is going to be rule 1. And so to combine this, you'd just be like, okay, log base 5, the of section, 16, the minus means it's divide, and the plus means it's times. So if you do your math right there, you'll get, after you reduce and everything, you'll get 4 over 27. That would be my answer. All right, looking at the next one, it's rather easy, but we'll go ahead and do it. 2 ln 4 plus ln 5. All right, well, this right here is rule 1. It's ln plus ln. Well, that's basically log base e plus log base e. So you can just call it ln of 4 times 5, which is 20. So you have 2 ln of 20. And then you can use rule 3 to get rid of this 2, take it to the power there. And so your answer is ln of 20 squared, which is 400. Hope that made sense. All right. Now, the only way that they're making this kind of weirder is like number 9. They'll put like a 2 in front of a giant parentheses of stuff. So like 2 log base 4 of 16 minus 2 log base 4 of 8 plus log base 4 of 3. All right, if I saw this problem, I would start here with this 2. I'd put it as that. All right, and then I'll go ahead and rewrite it just so I don't confuse you. 8 squared is 64. All right, so now it's just using a combination of rule 1 and 2 here for this middle part. So you're gonna have, let's put the 2 in front so we don't forget it. You're gonna have log base 4 of 16. It's a minus there, so it's divided by 64. And then the plus is a times 3. You could call it 3 over 1 if you want. So we have 2 log base 4 of, if you multiply this out, you'll get 3/4. So you have 2 log base 4 of 3/4. And then the last step, the whole reason I showed you this problem was to get rid of this 2 at the end. You go like this, just know it's grouped, it's parentheses there. So my final answer is log base 4 of the 3 gets squared, the 4 gets squared. This would be my answer. So that's how you'll do that first section there. So I hope I didn't confuse you too much because that's like the basics. All right, now they want me to find an exact value for each expression. That means I'm going to be evaluating. So basically, let's look at the first one. We've got 3 to the log base 3 of 5 minus log base 3 of 4. Okay, now to do this problem, I would probably start with the log part, so I wouldn't touch the 3, and I would group it using rule 2. So it'd be log base 3 of 5 divided by 4. Okay, now you're ready to, if you're evaluating, you're going to have to snail this. And so basically I would imagine an equals x that doesn't exist, and I would snail it. So I'm taking it to log form. My 3 was my base. The x is my of statement. And I finish with equals log base 3 of 5/4. So now you can just be like, oh, okay, well, the log base 3, those match. So the parentheses have to match. So this one, the whole answer is just 5/4. Not x equals 5/4 because that x was made up by me. You would just go, okay, that equals 5/4. That has a value of 5/4. So that's how you would do 13. Now 15 is a little trickier. And so it would look like this. I'm on 15 here. E to the log of e squared of 16. Okay, well, you're ready to go ahead and snail and convert it. So imagine it equals x and then do the snail. And so you got log base e, which of course is ln, but I'm not going to change it, equals log e squared of 16. Now, you have to get rid of this e squared. These have to match. They don't match currently. So I'm not 100% sure on this. I'm not going to lie. But the way that I kind of think about it is if I just root this and root this, it would look like this. and then they match, and then I'd have my answer of 4. So you may not want to quote me on this root part. It might be some other technical term, but that's how I do it. That's how I get to the value of 4. So, all right, let's move on. So that's how you would do 16 as well. Now we get to some of the weirder ones where they want you to break it up. So they've already, in this first section, we were combining it to make it one log statement. Well, now they want you to break it up to make it multiple log statements. So like, look at number 17. You have ln of x squared root 1 minus x. Okay. Well, when you look at this problem, you should probably be realizing that it's like x squared times the root of that. And so it's this right here. And so to break it up into 2, you break them apart and call it a plus in the middle. So it's like ln of x squared plus ln of the square root of 1 minus x. Okay. Now, this ln of 1 minus x under the root, you need to realize that it is the same thing as if you wrote 1 minus x to the 1/2. All right. And so why you would want to do this is because now they both have exponents, and you can use this third rule where if you have the exponent on the of section of the log, it can go be a number in front of that word. So my final answer here would be 2 ln of x plus 1/2 ln of 1 minus x. This would be my answer. So you break it apart first, and then you need to put things to the exponent so that you can swing that exponent out in front right there. Hope that made sense. So like that's how you would do this, the next one, number 18. Now let's just go ahead and jump to 19. You have log of x times x plus 2 over x plus 3 squared. Okay, you should be looking at this thinking, okay, the top part's an x, or is a log of something times something. So it's this rule, the first rule. And the bottom one is a divide. So it is this rule right here. So when you go to rewrite this, really you can think of it as log of, you had x times log of x plus 2 divided by log of x plus 3 squared. And then the last thing I would do to this problem is this 2 right here. So I'd have log x, I'd have plus log of x plus 2, and then I'd swing this in front here. So minus 2 log of x plus 3, just like this. Hope that made sense. So that's kind of how you would do like number 20. Now let's get to 21. And I don't feel like rewriting all that, so I'm just going to zoom in. I'm on 21 here. First of all, factor this. Basically, almost any time you see a quadratic, you should always like kind of try to factor it in your head, just see if it can work. Because if it can factor, there's probably a reason for it. All right, so you have a ln of something times something up top and then divided by something down low. I'm ignoring this 1/3 for now. That'll come in at the very, very end. So you could rewrite this as ln of x minus 2. Then it's a times that x plus 1. So it's plus ln of x plus 1. Then it's divide by x plus 4 squared. So it's minus ln of x plus 4 squared. Okay, now don't forget, this technically all is to the 1/3 still. I haven't even touched that yet. I'm still not going to, because I'm going to handle this 2 first. So it's going to be like ln of x minus 2 plus ln of x plus 1 minus 2 ln of x plus 4. And then it's all to that 1/3. All right, now I'm going to distribute the 1/3 And so basically it's going to look like this. It's just going to go and sit right in front of all these lens. So it's like a third len of x minus 2. It's like 1/3 len of x plus 1. And then it's a 2 times 1/3, so it's minus 2/3 len of x plus 4. Green would be my answer here. That one's a little tricky. Okay, moving right along. Now we get to the bottom section, which is just more of the same. And so basically you could start with like 24, for example. Len x plus len 2 would just be len of, multiply those, 2x. Just like that. So that one was really easy. Now look at 27. It would just be log base 3 of 5x, and then you would move that 1/3 here to become a power like this. So really it's like log base 3 of, you could make the power of 1/3 be called the cube root of 5x. So that would be my answer there. Now these don't really get that challenging until, well, we'll just keep moving. This one, you would be like, okay, well, this is log base 7 of z minus 2 to the 3/2. And then you could call that the square root cubed. So it'd be like log base 7 of the square root of z minus 2 cubed. Like that. That's probably how I would leave the answer. So that's how you do those. Now jump to number 30. And I don't feel like rewriting this one either, so I'm just going to dive right in off to the side here. Basically take those numbers in front and they can become powers. So it starts out like len of 5t6 to the 3/2. And then minus, I'll handle that in a second, len of t to the 4 to the 3/4. Now it's a power to a power, so I'm going to multiply these powers. So it's really like len of 5 to the 3/2. T to the 6 times 3/2 is 9. Minus len of t to the 4 times 3/4 is 3. All right, so now we can use our rule. Len of 5 to the 3/2. T to the 9, it's a minus, so it's divide by t3, like this. And so this part right here is going to make t6 on top. So really you have len of 5 to the 3/2, t to the 6. All right, well, 5 to the 3/2, it's the same thing as the square root of 5 cubed, aka the square root of 125. So my final answer here would be len of t to the 6 square root 125. Like that. That one's a little tricky. Okay, the next couple are pretty self-explanatory. Okay, let's look at 34. You would start out with this red section. This is a, well, actually, you would start with this 2 being squared here, but then you would do this red section. So it'd be len plus len. So you're multiplying this. So it's like y times y plus 4 squared, like that. I didn't mess with the 1/3. And I didn't mess with this end part. Okay, now you would pull the 1/3 and basically take it to this power right here. So it's going to be like len of this y times y plus 4 squared to the 1/3, then minus that len of y minus 1. Okay, Now you've got a power to a power here. So it's going to become ln of y to the 1/3 times y plus 4 squared times 1/3 would make it to the 2/3. And now that I've simplified all that, I can group this these two lns. It's a minus in the middle, so it's a divide. So it's like y to the 1/3 y plus 4 to the 2/3 over y minus 1. And I'd probably leave it like this. So that's how you would do that. You have to do this red grouped part first, then you can handle the 1/3, then you distribute that 1/3, then you can handle both of the ln sections. So I hope that wasn't too confusing, but anyways, that's properties of logarithms, and they're really important. So if I was approaching anything like this, I would make sure I had these rules written down. So hope this video helped.